Welcome to the lecture. Today I am going to discuss chapter 5, that is linear system of the book The Scientist and Engineer's Guide to Digital Signal Processing by Smith. So what are linear systems? Linear systems are those systems which follow superposition theorem. So what is superposition theorem? The superposition theorem is that when additivity and homogeneity, these two properties are combined together, then the resulting output is superposition theorem. So what is homogeneity and additivity? I have explained these two properties in the previous lecture in detail, but in this lecture I am giving just overview of these properties. So what is homogeneity? Homogeneity, when we multiply the input signal by a constant and that constant is multiplied at the output, then this property or this concept is known as homogeneity. The other property in the superposition theorem is additivity. When we add two input signals and the output is also the sum of the individual outputs, when individual inputs are passed through the system, then this is called additivity. When these two properties are combined, the result is called superposition theorem. The other requirement, these are the requirements of linear system. If we are checking that a system is linear or not, we have to check whether it is homogeneous, whether it follows additivity. Then the third thing that we have to check is shift invariance. When we apply a shift in the input signal and that shift is also obtained or viewed at the output, then the system is said to be shift invariance system. So are these three properties are enough to explain whether the system is linear or not? No. The answer is no. Because there are two more properties that have to be followed by a linear system. Those two properties are sinusoidal fidelity and static response. Let me tell you what is sinusoidal fidelity. When we apply sinusoidal signal to a system, and the output of the system is also a sinusoidal waveform and the phase of both these waves are same, then this is called sinusoidal fidelity. The next thing is static response. Static response states that the output is input multiplied by a constant. So if a system follows all these properties, then a system is said to be linear system. I have some examples to tell you whether the system is linear or not. First one, I have Ohm's law graph, because you guys love graph, and you know that Ohm's law states that V is equal to IR. So when we have greater voltage and low current, this means that the resistance is high and the graph is linear. So let me tell you, this Ohm's law is only valid for conductors, pure conductors. This is not valid for bulbs or tube lights, etc. The other example is Hooke's law. Hooke's law. You can say that F is equal to Kx or KL. I have written L. So you can say these systems follow linear lines. Let me explain the first one a little bit. This is voltage, this is current, and I have to find R, resistance. V over I. So first is, if V is equal to 1, I is equal to 1, the resistance is also 1. If this one, V is equal to 2, I is equal to 2, the resistance is also 1, and so this graph follows linearity property. There are some of the properties of linear system. These two were the examples of non-linear system. I will explain a little bit later. There are some of the properties of linear systems. Commutative. Linear systems are commutative, and you can see this is the complex system. So tell me guys whether this is linear or not. I think you are confused, but you can see that this is only this Mason, and there is no scalar multiplication, only one, I think. So you can see that it is only additive, and this system is linear. There is no multiplication sign. If there is multiplication, then this system becomes non-linear system. I have some examples of linear and non-linear systems. Let me tell you. The first one is wave propagation. Wave propagation is linear system because it follows linearity. It follows all the properties. Electrical circuits, such as those circuits having resistors, capacitors, inductors, are also linear system. I have given you the examples of Ohm's law. This relates to this one. Electronic circuits, such as amplifiers, filters, these are also linear systems. Mechanical motion, dampeners, etc. are mechanical, and the other Hooke's law is also mechanical. The other example is unity system. So what is unity system? When we feed input to a system and the system gives the same input as output, I am giving x sub n to the system and system gives x y of n is equal to x of n. So this kind of systems are unity system. As you can see, this returns the same input, so it should follow linearity. So this is another example of linear system. Null systems are also example of linear systems. So what are null systems? Whatever we apply the input to the system, the response of the system is null. System gives you zero output, null output. Those systems are linear systems. So those are some of the other examples. Multiplication of a signal by constant, as I have told you that homogeneity is the example of this one. Convolution. What is convolution? Convolution is the sum of shifted scaled versions of inputs. We will discuss this convolution in detail in the upcoming lectures. Recursion is also example of linear system. In recursion, instead of inputs, there is previous versions of output. Recursion states that the output is the sum of scaled previous versions of outputs. Here are some examples of non-linear systems. The systems that don't have static response, such as V is equal to, P is equal to I square R. Power. This is non-linear. You can see. Let me tell you, linear systems only have the maximum power of 1. As in this case. Whenever the power increases, the system becomes non-linear. Its behavior is non-linear. The other is hysteresis. Hysteresis. I have drawn this, but I haven't explained. But now I am going to explain. Change of electric flux changes the magnetic flux changes magnetic intensity in iron. Then the concept is called hysteresis. So you can see that this graph is a little bit in this shape. This is non-linear. These systems are non-linear systems. Similarly, saturation is also non-linear. Systems having threshold value. Let me tell you. The example of silicon diode. It has a threshold value of 0.7, but it conducts after 0.7. So these systems, you can see that these are nonlinear systems. Similarly, common electric distortion, and another thing that I have explained earlier is multiplication of two signals. Is also a nonlinear, because the resulting signal is the product of the input signals, and we don't know how it will behave. It will not behave linearly. So these were the examples and quick review of linear systems. If you have any query, you can consult the book, and if you have questions, kindly ask in the comment box. Thank you very much.